Okay, now I'm going to go over this a lot quicker. Okay, so put in your operators, you're simplifying it. 5 times m to the 6th to the 2nd, m to the 3rd. Okay, so we got 5 times m times m. Okay, that means just a plus to your m. So 1 times 2, 2. M, you got to take 6 times 2 from here, that's 12, and then 3 here. So 12 plus 3 is 15. Okay, exponent positive, that's a stay. Exponent positive, that's a stay. Okay, you can simplify 5 to the 2nd. That's 5 times 5, so that would be 25. 25 times m to the 15th power. Okay, next one. So 2, underline the expression. So 2 times x. I know I didn't up here. That's my fault. Okay, so 2 times x. Now they're both to the 1 power, but they both have to be multiplied to the -4. So you're going to have a -4 and another -4. Well, guess what, Sparky? That's got to switch positions. So the 2 heads to the bottom, so it becomes a 4. The x heads to the bottom, becomes a 4. Okay, now you need to, you can simplify 2 to the 4th. You need to put a 1 on top. If you don't have anything on top, you can have nothing on bottom, but the top you need a 1. So 2 times 2 times 2 times 2 is 16. So that's a 16 times an x to the 4th. Okay, number 3, remember 2 multiplying fractions, you just make it into 1. So you got 2 to the 3rd times 3 times x to the 4th, then a 4th. Now in the denominator you have x to the 2nd times y to the 2nd. So 2 times 3 times x. Okay, so 2 to the 1, 1 times 3, 3. 3 to the 1, 1 times 4, 4. Now x on top, 4 times 4 is 16. Okay, now on bottom you got x times y. So the x, 2 times 3, that would be 6. And then 2 times 4 would be 8. Now can you cancel anything? You can cancel with the x's. So that would be a 6. But now 16 minus 6, and it was just 6, so it's minus 6, so that'd be 10. Okay, how about that, guys? That's switch or stay. That's stay. Switch or stay, stay. Switch or stay, stay. And on bottom, switch or stay, that's a stay. Okay, now what can I simplify? Well, 2 to the 3rd and 3 to the 4th. I can't simplify the letters. So 2 to the 3rd, 2 times 2 times 2, that's 8. 3 to the 4th, 3 times 3 times 3 times 3, that's 81. The variable stays the same. X to the 10th, y to the 8th. Okay, now you can multiply here. Okay, 8 times 81, you have to stop the times when you get to the letter, but 648. So that's your answer, 648 times x to the 10th over y to the 8th. Okay, next problem. Keep in mind, you do have a parentheses, but it's just right here in that little space here. This, and this are not in parentheses. So you got 2 times e, -4th, times g to the 5th, e to the 5th times g to the -3rd. So we got 2 times e times g. Okay, then on bottom you have e times g. So you'll do some canceling, but you got to know what the exponents are. So 1 on the 2, 1 times -4 is -4. Then the e, 1 times -4 is -4. Then the g here is just a 5. Now the e and the g on bottom are not in parentheses, so we just put a 5 and a -3. Okay, canceling can be done. If you have a -4 and a 5, you get rid of the -4, but it's not 5 minus 4, it's 5 minus -4. Okay? 5 minus -4 is the same as 5 plus 4, regular, and that's 9. So it's e to the 9th. The g you can cancel, but it ain't 5 minus 3, okay? It's 5 minus negative 3, which is 8, okay? You use a calculator, I mean, it'll show it. Okay, 2 to the negative 4, oh, that's a switch, so that base 2 goes into the bottom so that its power can become positive. That's a stay, g to the 8th. And down here, e to the 9th, the exponent's positive, so we keep it down there. You keep it in the position it's in, top, bottom, so forth. Okay, g to the 8th can't be simplified. 2 to the 4th can be, okay. That's 16. Variable. Okay, scientific notation. Remember, these are two separate numbers, here and here. You need to multiply them correctly. You take your two standard numbers, 7 times 6.3, and then you multiply your base 10s. You're splitting up the multiplication. So you take the 7 times the 6.3, that's 44.1, times, and then on 10, I add 5 plus 6. 5 plus 6 is 11. Now, make sure decimal's in the right place. This is the first digit. That's not a 0, okay? It can't be a 0, but that's the first digit. You need to move the decimal so it's right after that digit. So 1, and I'm there. So I put a 1, and since I moved left, I add 1. So 4.41 times 10 to the 12th power. Okay, now we're dividing. Okay, so same idea, but now you're just dividing those standard numbers. And you're dividing the base 10s. So 2.4 divided by 3 is 0.8. Times, cancel the bottom one. It's not minus 5, it's minus negative 5. 8 minus negative 5 is like 8 plus 5, which is 13. So that's actually becomes 13. Now, the one digit you have can't be a 0. If it's 0, you got to move it. So you move it here so that the 8's now in front of it, be 8.0. So I moved it once, and I moved it to the right, meaning I will be minusing. So 8.0 times 10 to the 12th power. Okay, exponent graphs. 2 times 1/4 to the x power. Just go to your input-output table. Do your calculator. Remember, this is shotgun. 2 times 1 ABC 4. Close parentheses, caret 2, 1/8. If you don't like that, you can divide it later. Now click the up key on your compass, and instead of caret 2, we're going to go caret 1. 1/2. Click the up key instead of caret 1, put in 0, it's 2. Instead of caret 0, we're going caret negative 1, that'd be 8. As far as why we get these outputs, I've discussed those in previous videos, but for now, 32. If these fractions drive you nuts, you can divide them into decimals, 0.125, but it doesn't really matter, so 0.5. Okay, what's your highest extreme number? 32. So on the x-axis, we know we need 1, 2, -1, -2. We have to get up to 32. So probably 5s would do the job. 5, 10, 15, 20, 25, 30, 35. So -2, 35. So that's going to be between the 30 and the 35. Graph those ones first. Graph the more extreme side first. -1, 8. Okay, 0, 2, and then all that happens with those little fractions and decimals, they just take you closer to the x-axis. Here you don't cross it, it just gets tinier and tinier. Next problem, okay. y equals 1/2 times 4 to the power of x. So m and b's out the window here because it's an exponent, it's not a linear. Okay. Okay, 1ABC 2 times 4 caret 2. I got 8. Just click the, rather than re-enter it, just click up on your compass, and instead of caret 2, you go caret 1. Now 1's the input, 2's the output. Now 0's the input for x, 1/2. Now negative 1's the input for x, 0.125, 0.03125. Okay. If that fraction's driving you nuts, just take 1 divided by 2, it's 0.5. Now the most extreme side starts here. Okay, we have to get to 8. So we can make that by ones. 1, 2, 3, 4, 5, 6, 7, 8. Remember, if 8 doesn't work, if that doesn't work, go by 2s and 5s, 10s, something easy to go by. So 2, 8. 1, 2, 0. And then you just get closer to the line. Okay, you never cross it. It just gets infinitely higher in that direction. Here it doesn't get infinitely lower, it just gets infinitely closer to the x-axis. Okay, these are easy if you know what you're doing. All you got to do is rewrite the expression in radical form. This is a radical. It is a 2 because that's what's on the bottom. So once I put that 2 in the radical degree, I can just put the rest of the expression inside. So 64x to the 1 power. I don't need it simplified. I really don't. Okay, now it's in a radical. You got to write it with an exponent. So the base you have is x. You put its 4th power, and then all you do is underline it and put 5. Now it's out of radical, and now it's got just an exponent. Rational exponent means it'll be a fraction. Okay, compound interest. A bank client deposits $5,000 in a savings account that pays 3% interest compounded quarterly. How much money is going to be in that account after 2 years? You don't need boxes and tables for compound interest. The formula's already been, we have the formula. A equals P times parentheses 1 plus R divided. You don't have to memorize this, it's on the board. Okay. But you have to know what each one represents. So P is your money, 5,000. R is your percentage, but you got to write that as a decimal. So you put the decimal here, move it twice, once, twice. So 0.03. N is the frequency. It says, look after the word compounded. You'll see quarterly, that means N is 4. Semi-annually means 2, monthly 12, and so forth. And then T is your years, which is 2. So P, you've got 5,000. 1 plus your R, 0.03 over N, so that's 4. Caret N times T. Well, 4 times 2 is 8, so it's to the 8th power. And you're ready to find A, okay? So again, we don't need to recreate the wheel on that problem, meaning boxes and tables and all that, when I have a perfectly okay one to get it. 5,300, just put 5,338. 308. I don't care about the rounding, but 99 cents means it's 308. Okay, the value of a car is $13,000. The car loses value at a rate of 15% per year. Approximate the value of the car if I decide to sell it in 10 years. Now we're not talking compound interest, we're talking dollars and years. X is years, Y is dollars. So dollars per year. Well, it doesn't exist, okay? Oh, there's something happening per year, but it's 15%. Losing it means minus 15%. So since it's by percent and not by dollars, that makes an exponent function. So when I set up my table, I'm going to be multiplying every time instead of adding. Now you got to get your decay factor. You need to take 100% every time that happens and minus your 15%. So it's 85%. And move the decimal twice. So 0.85 is what we're multiplying by. So when I set up my table, dollars and years, we're going 0, 1, 2 because that percent does take place every single year. And you start at 13,000, but you don't add. You start multiplying by your decay factor of 0.85. $11,050 times 0.85 again. Okay, I don't care about the 0.5, just put 9,393. Okay, and they want the 10-year value. Now, we don't make a line with this. It is not linear, it's exponential. To write your own equation for that, it's a times b to the x power equals y. It's that simple. So 13,000 times your 0.85. And then the power of x, it's going to be 10 equals y. Just go to your calculator, you got it. 13,000 times 0.85 to the here. Okay, $2,559. Okay, so that's what he could expect to sell it for. Okay, then the last problem, this might be on the test, it might not be. A person's body usually produces 2.5 times 10 to the 6, that's a scientific notation number, red blood cells per second. How many red blood cells can the body produce in 20 minutes? So you take that scientific notation number, and per second means you just times it by seconds. We don't need to use variables and equations to solve this. Now if that's minutes, every one of those minutes is 60 seconds. So you take your 20 times your 60. 20 times 60 is 1,200. So now you take your 2.5 times your 1,200, those are the standard numbers, and then you just have your base 10 to the 6 sitting there. So 3,000. Put a decimal after the last 0 because that's where it's at. 10 to the 6. Problem is decimal is supposed to line up right after the first non-zero number, so you need to move it 3 times. And you moved it left, so you're going to add 3. That's 9. Okay, so 3.0 times 10 to the 9th power.